Imagine for a moment the very fabric of your reality shifting, not with a cataclysm or a sound, but with a simple, profound change in the rules of physics. The force that has anchored you to this world since your first breath has just been dialed down. This is not our world anymore. What you are about to see is a log of that new existence. Look around your home. What do you see? The books on the shelf, the mug on your table, they haven't moved, but their relationship with the world has been fundamentally altered. Now watch what happens when a simple door is closed with familiar force. It swings shut, not with a solid thud, but with a weightless, almost hesitant glide, its mass offering less resistance. That pen you left on the desk? It now rests a hand's breadth from where you placed it, shifted by a draft that would never have moved it before. This is the new normal. Walk with us, but be mindful of your step. Your body, honed by a lifetime of fighting a stronger pull, is now over-engineered. Your first instinctive stride would send you lurching forward, your momentum unchecked. You must learn to walk again, not with a shuffle, but with a deliberate, elongated pace, almost a glide, keeping your center of gravity low and controlled. Observe the dust motes dancing in a sunbeam. They hang in the air longer, tracing complex, lazy paths in the still air. The pendulum of a grandfather clock swings with a languid, reduced arc, no longer keeping accurate time. Water poured from a pitcher no longer forms a steady stream, but a wobbling, coiling rope of liquid that splashes in slow, large droplets. This is not a world of chaos, but a world of recalibration. Every action, from the grandest engineering feat to the simplest domestic chore, must now be relearned under a gentler sun. The very planet has become a different classroom, and humanity, its reluctant students, must take their first cautious steps into a lighter future. Now, let's descend from the grand skeletons of our cities and examine the lifeblood of our modern world, its movement. What happens to the intricate, pulsating network of transportation when the fundamental force of traction is fundamentally reduced? The wheels that carried us, the wings that lifted us, they are all suddenly operating in a new and unforgiving physics. Picture the familiar sight of a vehicle on a highway. Its tires, engineered for maximum grip under Earth's former pull, now meet the asphalt with a fraction of their former commitment. The friction that allowed for acceleration, for braking, for simple control, has become a ghost. A gentle turn of the steering wheel, a routine application of the brakes, becomes an exercise in controlled drift. The vehicle slides with an eerie fluid grace, its mass no longer pinned firmly to the road. This is not a matter of power, but of contact. The roar of an engine now translates to spin and slip, not forward thrust. And what of flight? Consider the aerodynamics of takeoff. An aircraft's wings generate lift by moving quickly through dense air, fighting gravity's pull to become airborne. In this new reality, that fight is considerably easier. The same wing, with the same engine thrust, now finds the air more than adequate to achieve liftoff in a startlingly short distance. Runways that were once necessary ribbons of tarmac suddenly seem excessively long. The challenge shifts from achieving lift to managing it, containing a machine that wants to leap into the sky long before it has reached a safe speed for a controlled ascent. But this same gentle air presents a new danger during descent. With less gravitational pull, braking in the atmosphere becomes less effective. A landing approach becomes a longer, more delicate ballet of reduced angles and earlier deployment of flaps and spoilers, all to compensate for a planet that no longer pulls objects down with its former insistence. The very concepts of heavy and light in navigation have been rewritten, grounding fleets and forcing a complete reimagination of how we design everything from the tread on a tire to the curvature of a wing. The world hasn't shrunk. It has become more slippery, and regaining our grip is the first and most vital step to reclaiming our mobility. Now let us turn our gaze from the intimate confines of the home to the colossal skeletons of our cities. These towering structures of steel and concrete, these sprawling bridges that stitch landscapes together, they were all conceived in a different reality, built to withstand the relentless, crushing embrace of a stronger gravity. So, what happens to this engineered world when the anchor line is suddenly slackened? The answer is not collapse, but a profound and silent sigh of relief. These giants are no longer under the same strain. But this reprieve is not without its new, peculiar challenges. Look up at the skyscraper. Its immense weight, once a constant battle for its foundation, has been significantly reduced. The very forces compressing its lower floors have eased. Engineers, armed with sensors and a new set of calculations, would find that the building behaves differently. It is not unstable, but it is springier. A strong wind that would have caused a slight calculated sway now induces a more pronounced, slower oscillation. The structure is safe, but it is learning to move in ways its designers never fully anticipated. Now, direct your attention to the arteries of our power grid, those vast webs of cables strung between towers. Their heavy, icy coats in winter, a deadly burden in the past, now hang with less threatening intent. Yet, the reduced pull means the cables themselves possess a different tension. They sag differently between pylons, swinging with more freedom in the wind. This is not a failure, but a new state of being that requires immediate and precise intervention. Crews are not tasked with reinforcement against crushing weight, but with a delicate recalibration of balance. They add new guy wires, not to hold the structures down, but to control their newfound buoyancy and dampen their leisurely, large amplitude dances. The goal is to tame this gentle float, to introduce stability into a system that has been granted an unexpected reprieve from its lifelong burden. The work is not about strengthening, but about fine-tuning. It is a global operation to teach our static, monumental world how to exist in a state of perpetual, manageable lightness. The very definition of structural integrity is being rewritten, not with thicker concrete, but with smarter, more adaptive designs that understand the subtle yet powerful language of a weaker gravitational field. We have secured our homes and stabilized our infrastructure. Now let's project our vision forward to the very process of creation itself. What happens when the architects and builders of our world are handed a new set of fundamental rules? The limitations that once dictated the form and height of our structures have been dramatically relaxed. Imagine a construction site. The cranes, their powerful motors now operating against a fraction of the former resistance, can lift payloads that were once unimaginable. I-beams that required the mightiest of machines to hoist into place now ascend with a newfound, almost graceful ease. This is not merely about doing old tasks more efficiently. This is about enabling a new scale of ambition. The concept of a heavy load has been permanently redefined. Now observe the materials themselves. Concrete, the gritty backbone of our civilization, was always strongest under compression, perfectly suited to bear down on its own foundations. But in this new reality, the crushing weight it was designed to endure is gone. This opens the door for innovation. Lighter, stronger composites and alloys, once too expensive or impractical for widespread use, now become the materials of choice. The very economics of construction shifts. But this new freedom demands a new kind of discipline. With the vertical pull so reduced, other forces gain relative strength. The lateral push of the wind becomes a dominant design consideration. A tower that feels barely any downward force can still be toppled by a storm if its foundations and form are not designed to resist shearing and twisting. So the shapes of our future cities change. We might see broader, pyramidal bases for stability, or more slender, flexible towers designed to sway harmoniously with the wind, their motion a feature, not a flaw. The architect's pencil now sketches with gravity as a secondary thought, while aerodynamics and tensile strength move to the forefront. The skyline of tomorrow will not just be taller, it will be smarter, lighter, and born from a completely reimagined relationship between mass, space, and force. This is the dawn of a new architectural language, written not in stone and steel, but in the calculus of gentle gravity. So we have seen the macro-scale adjustments, the recalibration of our cities and machines. But where does this transformation become truly personal? It is within the walls we call home. This is the environment we must master first, the intimate space where the new physics meets daily life. Let's conduct a simple thought experiment. Look at the floor beneath you. Its smooth, hard surface was once a reliable plane for traction. Now, it has become a potential slide. Each step requires a conscious calculation of force and friction. The simple act of walking across a polished kitchen floor to get a glass of water is no longer an automatic function. It is a learned skill, a deliberate placement of the foot to prevent the body from gliding forward uncontrollably. This is the new domestic reality. Now, observe the vertical plane. Stairs, once ascended with a familiar rhythm, now present a different kind of challenge. With each step, the body floats upward with unexpected ease, but the descent requires a new caution. The risk is no longer just tripping, but a slow, uncontrolled bounce downward. The solution emerges not in demolition, but in adaptation. Hands once used for balance only for the very young or old, now find a constant role. Sturdy rails appear along every wall, on every staircase, transforming corridors into pathways defined by touch and grip. Underfoot, smooth flooring is replaced with textured rubber or deep pile carpeting, its fibers acting as 1,000 tiny anchors to catch the sole of a shoe. And look at the furniture. A bookcase, once stable under its own weight, can now be toppled by the casual lean of a body that has misjudged its own force. A simple act like opening a stiff window could send a person stumbling backward. The response is methodical and universal. Every tall piece of furniture is securely bolted to the wall. Cabinets have latches that click shut, preventing their contents from drifting out. The home transforms from a static collection of objects into a dynamic, secured environment where every element is braced for a life of reduced weight, not increased force. It is a silent, ongoing project of anchoring a world that has chosen to float. Now, let's journey from the sporting arenas to the very source of our sustenance, the land. What happens to the silent, ancient contract between plant and planet when the planet's pull is weakened? Consider the humble potato, the carrot, the peanut. These are root crops. Their edible parts evolve to push down and expand through dense, resistant soil. Their growth a constant struggle against the downward pull that also gives them structure. In this new reality, that resistance has faded. The soil offers less mechanical opposition. The result is not a failure to grow, but a change in form. The tubers are smaller, more numerous, and often misshapen, lacking the firm, compact structure we know. They emerge from the ground more easily, but with a compromised yield and a different texture. This is a fundamental redesign of the underground larder. Now, lift your gaze to the orchards and the forests. A tree's trunk is a masterpiece of engineering, a vertical column designed to support a massive canopy against the constant strain of gravity. With that strain reduced, the imperative for thick, dense wood diminishes. Trees grow taller, faster, reaching for the sun with less investment in girth, but this makes them vulnerable. A strong wind that would have once rustled their leaves now poses a greater threat, able to snap these slender giants or topple them entirely, as their root systems too experience less anchoring force. The entire landscape becomes more volatile. Agriculture must adapt not to a changing climate, but a change in physics. Farmers can no longer rely on traditional planting patterns and support structures. New, lighter trellis systems made of strong polymers are woven through fields to support taller, more fragile grain stalks. Vineyards become intricate webs of support wires, cradling the vines that can no longer trust their own woody strength. The very practice of farming transforms from a battle against pests and weather to a delicate act of structural engineering, of building external skeletons for a kingdom of life that has lost its internal fortitude. The green world is still fertile, but it must now be propped up, taught to stand tall in a world that no longer holds it down with the same firm hand. Now let's shift our focus from the built environment to the human body itself, and the realm of physical achievement we call sport. Imagine an Olympic stadium. The running track, once a surface for powerful grounded strides, has become a launch pad. A sprinter's explosive start, the same force that once propelled them down the lane, now sends them on a long, low arc, covering distance not in steps, but in bounding leaps. The very event transforms from a test of rapid leg turnover into a discipline of controlled trajectory and precise landing. The long jumper, a specialist in a single, powerful leap, would find their carefully honed technique obsolete. Their run-up would need to be recalibrated, their jump a cautious application of power to avoid launching too far, even clearing the pit entirely. The sport becomes less about raw power and more about the exact modulation of force. Now direct your attention to the weightlifting platform. The steel barbell, a symbol of ultimate strength, has lost much of its intimidating mass. A weight that once represented a lifetime record now bends the knees only slightly. The challenge is no longer heaving immense mass upward, but controlling it in a world with weak downward pull. The clean and jerk becomes a different kinetic puzzle. The athlete must generate power to get the weight moving, but then must arrest its motion at the apex, preventing it from floating free. The grip becomes paramount, as the barbell seems to want to escape the hands. Entirely new sports emerge built around this low-gravity physics. Imagine a form of basketball played in a stadium with 20-foot hoops, where players can execute multi-second hang times, passing and maneuvering in mid-air. Or a gymnastic discipline performed in vast halls, with apparatuses designed for routines of unprecedented aerial duration and complexity. The old records become relics, the old stadiums, museums. Human athletic potential is not diminished. It is redirected, creating a new spectrum of physical poetry written in the language of flight and gentle descent. The arena of sport becomes a laboratory, exploring the new limits of a body liberated from its heaviest chains. Throughout this journey, we have observed the external world adapting. Our cities, our machines, our food supply. But now, we must turn the lens inward to the vessel that carries us through this new existence, the human body itself. This biological machine, refined over millennia, under a constant strong gravitational load, is now operating in an environment for which it was never designed. Consider your own skeleton. Its density, its very strength, is not a static gift but a dynamic response. Bone mass is maintained through constant stress. The microstrains of walking, running, and lifting, sending signals to the body to continually rebuild and reinforce. Remove that load and the signal is lost. The body, in its relentless efficiency, begins to dismantle what it perceives as unnecessary structural support. The result is a gradual, silent loss of bone density, a skeleton becoming more fragile, more porous with each passing day. Now direct your attention to the muscular system. The powerful muscles of the legs and back, the calves that propelled you against a strong pull, the core that stabilized your upright posture, they are now overbuilt. Without the constant resistance they evolved to overcome, they begin to atrophy. The body, always conserving energy, will not sustain tissue it does not regularly use. A simple stroll no longer provides the necessary workload. The gentle glide of a low-gravity step is a fraction of the former metabolic demand. But the body's adaptation does not stop at the bones and muscles. Even the cardiovascular system is affected. The heart, a powerful pump, no longer has to fight as hard to push blood upward from the feet against a strong gravitational gradient. Its workload lightens. Over time, this can lead to a reduction in its muscular strength and efficiency. The entire human organism is deconditioning, softening from the inside out. The response to this is not medical in the traditional sense, but a new, non-negotiable daily discipline. Every individual must become an astronaut on their own planet, engaging in a strict regimen of high-resistance exercise. Elastic bands, weighted suits, and vibration plates become household staples, not for fitness, but for survival. The daily workout is no longer about vanity. It is the essential maintenance required to fool the body into believing it still lives in a world that pulls with a familiar, strengthening force. The greatest challenge of this new era is not rebuilding our world, but preserving the fundamental integrity of the human form within it.